In this example, we're given two graphs. We're given the first one, and we're given the second one, and they're telling us that there has been either a vertical or a horizontal or both that have happened. So I'm going to show you how, in this example, we could figure this out simply. And then I'm also going to introduce you to a technique that we're going to need to use when it gets more complicated. This is considered a simple question of this type because it just has horizontal compressions and vertical compressions or stretches. When they get more complicated, you'll have both stretches, compressions, and translations together. In this example, what you can do is look at corresponding points. So we think about the graph. Can you see which one's the original one? The red one's the original one. So I'm just going to put a red box around that so I can picture that. My red graph is the original graph. I have the point 2, -8 on my original one, 3, 9, and 0, 0. Those are the 3 points that they have labeled. And then on the blue graph, what happens to 2, -8? It's at 1, -4. What happens to 3, 9? It's at 1.5, 4.5. And what happens to 0, 0? It's still at 0, 0. Let's look at our x values. What's happened? X went from 2 to 1, 3 to 1.5, and 0 to 0. Can you describe what you've multiplied x by? 1/2. If we look at our y values, we went from -8 to -4, 9 to 4.5, 0 to 0. What's happened to our y values? Also by 1/2. So if we just have stretches and compressions, you can look at the points and you'll be able to figure it out right away. We multiplied our x values by 1/2, our y values by 1/2. Write an equation of the image graph, write an equation of the blue graph in terms of the function f. In other words, write it in function notation, which is good because we don't know the explicit notation of this graph. Well, how do I write y by 1/2 and x by 1/2 would the y by 1/2 be in front of the function or inside the function? In front. Would it be 1/2 or would it be 2? It would be 1/2. Then I'd have inside my function, so my function is f, so I'll write f here. Inside my function, because that's what happens to all my x values, I have to multiply x by 1/2. So what would show up inside the function? 2. And that is the function notation and the equation in terms of the function f. Okay? Now the technique that we are going to develop later on, okay? This, I think this makes a lot of sense. This next part's a little bit more complicated, but you'll need it for later, so that's why I'm introducing it now. What you're going to do is you're going to compare your graphs. So first of all, let's do a horizontal comparison. I'll write another method. You're going to choose 2 points on your original one. So I am going to choose, and we're going to label these, but let's label this one A and this one B. And then on our blue graph, the corresponding points on the image, we write with a little mark above them. So we'll mark that one A prime and that one B prime. Okay? So horizontally, what we're going to compare is originally, what's the distance from A to B? And then on the image, what's the distance from A prime to B prime? And just horizontal distance. So from A to B, I went from 2 to 3. So my distance is positive 1. And from A prime to B prime, I go from 1 to 1.5. So my horizontal distance is 0.5. Can everybody see on the graph how the horizontal distance from A to B was 1 and A prime to B prime was 0.5? And if you compare those, what's happened? The distance has been multiplied by a half. So we will conclude that x has been multiplied by half. We do the same thing vertically. We look at A to B and A prime to B prime. From A to B, we go from -8 all the way up to 9. That vertical distance is going up 17. And from A prime to B prime, we go from -4 to 4.5. That distance is going up 8.5. To go from 17 to 8.5, your y values have also been multiplied by half. So right now, when looking at this whole thing, you'd say, well, Mr. JR, the first method we did makes way more sense. It's a lot easier than the second method, okay? But later on, when we add moving things left and right, the first method won't work for you. And so you'll have to use the second method to start before you can go back to the first method. Yes?
So are you picking your number by like what you multiply by? Because it's A prime to B prime, like, or are you picking it because it's a smaller number?
I'm picking it as when we go from here to here, what would we have to do? When we go from 17 to 8.5, what do we have to do? To get to 17, I'm using vertical distance from A to B, and then vertical distance from A prime to B prime. So that's where I get my measurements from my graph. But when I'm figuring out this value, that's by looking at what was it originally and what is it in the image.
Will it always be that mix of numbers to know?
Mostly. I think sometimes the worst, like this is a fraction, right? I've seen multiply x by 4/3, so they can get a little bit not nice. Generally on the exam, they're mostly nice. Okay, questions for practice on this one are 5, 12, 13, and 14.